Hello everyone, my name is Matt Peachy. Today I'll be giving a quick presentation and demo about using FAUST with libmapper. And so the motivation behind this project is that Functional Audio Stream, or FAUST, is a programming language for audio processing and sound synthesis. And so the community has created many synthesizers, plugins, and lots of other projects that heavily require DSP in the FAUST ecosystem. And of course, there's the opportunity to create our own unique projects in the language as well. And so one of the main features of FAUST is that any FAUST project can be compiled to many different languages or platforms. And so I've listed some examples such as C++, WebAssembly to deploy to the web, Bella, and Daisy, and many, many, many more. And so then the question that we ask is, how can we bring FAUST projects into the libmapper ecosystem? And so the way we do this is with FAUST via HTTP control. And so what this means is that most of the FAUST projects will support remote control, meaning that you don't have to interact directly with a GUI, but rather interact it sort of headless or remote style. And they do this by exposing the synthesizer's parameter space to the users via JSON. And so I've shown one simple example of this for the attack time parameter in a simple synthesizer. So you can see there's a type, which is it's showing that it's a slider. There's a label, an address, which is how you interact with this parameter, and then some metadata as well as other values meant to help sort of initialize and manage the behavior of that specific parameter. And then to update parameters, you're able to submit a simple HTTP GET request. And so in order to change the attack time or update the attack time that I've shown in the image above, you would be able to go to the actual URL listed below, and you can see that the address of the URL matches the address in that JSON. And so to connect libmapper, what we've done is develop a script that automatically discovers the parameter space rather of a FAUST synthesizer, and it does that through that JSON. It saves all the metadata that we listed for each of the parameters, and then it creates a libmapper device which encompasses the entire synthesizer. And then for each synthesizer parameter, a libmapper signal is created as well. And so in the callback handlers for each of these signals, what it does is it takes the signal, it grabs the value, scales it to the appropriate range using that metadata it's already gathered, and then sends an HTTP GET request to update that FAUST synth. And so a simple architecture diagram in here is seen that you have a libmapper device with many libmapper signals. Each of those signals have a callback handler that via HTTP updates a FAUST synth. And so the result of this is that you're able to bring FAUST synthesizers into WebMapper or any other WebMapper manager and map other devices to those synthesizer parameters rather. And so I can show a quick demo of how this works now. And so what you can see now is a webcam, but what this is for is MediaPipe, which I have also added a bridge to libmapper for. And so what MediaPipe does in this instance is it's doing pose estimation of hand joint data. And so essentially I have it set up currently so that the libmapper signal is sending the values of the index finger sort of top joint. And so what I have done is I've mapped that using WebMapper, which you can see in the background of the screen, to the frequency cutoff parameter of a synthesizer. And so speaking of the synthesizer, you'll notice the gray rectangle is actually the FAUST synthesizer running on my machine. And then you'll also see that the parameter space is matched one for one here in WebMapper as well. And so like I said, I've mapped the index position or the index finger position via MediaPipe to the frequency cutoff of the synthesizer along the x-axis. So if I take my hand and put it over here, you can see the frequency cutoff parameter as I shift across the screen moves with it. And so that is how it's being mapped. It's just a one for one right now. And so then if I also were to play some sound, I have a MIDI keyboard here to my right. If I play a sound and then also move my hand, you should be able to hear the effect from that mapping. So. And so, of course, those are just simple chords, but you can hear the filter effect taking place thanks to the mapping between media pipe hands and the FAUST synthesizer via libmapper. And so finally, a bit of our future work. This includes optimizing the script that we've developed to ensure compatibility with any of the FAUST synthesizers, using recursion in order to make sure that all of the parameter space is discovered. Simply because some users develop FAUST application and that everything is very nested UI elements, which directly relates to the JSON that is exposed. And so another question we've had is, rather than using HTTP for remote control, should we try to integrate it with OSC, Open Sound Control? And the reason for this is that Open Sound Control is actually one of the fundamental building blocks of the libmapper project. And so relying on a single protocol may produce better results, but we haven't confirmed that yet. So it's an area we'd like to explore. And so then finally, we'd like to make the project more widely available to the libmapper community. And so this would involve simply uploading the existing code and some tutorials to version control, such as GitHub and the libmapper website, etc. So thank you for taking the time to listen. And of course, if you have any questions, feel free to get in touch with me. Have a good one.